Okay, this is Duncan Foley, and we're going to work through tutorial defining a robot cell. So if you boot up the Stubli Software, and the first one we're going to do is go to the settings and go to the emulator and make sure that this starting standalone mode box is ticked. Don't worry if you don't see anything behind that, simply because I've been working on a previous project. But just make sure that the starting standalone mode is ticked. Go back to the home page, and I'm working along with the booklet that I've written, so I'll try and keep referring back to that where appropriate. So we've changed the emulator, and we're going to do a new cell. We're going to use the new cell wizard. You shouldn't get this. This is simply because I've been working on something previously. Okay, it is very important that you make sure that this path is somewhere that you can get access to after you've logged in. So place it somewhere in that you'll be okay with to go back to later on. I'm going to call this tutorial Stäubli underscore template underscore df. If at any point you give it your application a name and it goes red, it's simply because in this forward path you put there's a cell named exactly the same. Let's select next, and we're going to add a controller. So go to the controller option, and it's looking for all the different types of robots and controllers that Stäubli produce. We know that ours is a TX. This might be slightly different on yours. It's but you should be able to find the TX feature. TX40 is our robot at the university, and it's floor mounted horizontal base cable. Floor mounted horizontal, so it's this one. So go to next. We want to have some basic input output ports. Next, don't worry if it's slightly different to yours. Mine's a newer model, a newer software, and press finish. This takes us to the Stubli Software. Our application program is named along the top. You might find that you're on the home page. And click on the Show 3D View, and hopefully your robot appears here. We've got along the bottom, we've got this error list. I'm just going to close that, and I'm going to close the output as well, just to give us a bigger screen. If we look along the right hand side, we've got the Stäubli template df, we've got the controller, the robot, but we haven't developed any applications yet, and that will be similar on the data and on the geometry as well. Okay. Okay. So if we go back to this the Cell Explorer, and we right click on the robot, well, you can do this by selecting it in the scene, right click, and we're going to look at, okay, I'm going to actually, instead of using the Cartesian, use the joints, and you can basically slide these around, move the robot into position, and then send it back home. Have a look at these, play around with them a little bit, and then when you're happy, send everything back to its zero position. Now let's bring in some 3D models that Chris Staines has produced for us. So I'm going to go to the modeling tab, insert some 3D, and you will need for this tutorial, you need the bump tray, the table, and the gripper. All three are IGES file formats, so I'm going to go and find them on my desktop. Okay, so I'm going to get the table first. Leave it at a standard position, and you can see it coming in down the bottom right hand corner. Just to clarify, the Stäubli Robotics Suite software isn't a 3D modelling package. Yes, you can do some really basic stuff, but I wouldn't recommend doing anything complex at all within here. Go away and do it in whatever CAD package you like, Fusion 360, AutoCAD, or the like. Okay, so it's zoom extents all. You can see that our tables come in. I'm just going to get rid of the joint down the right hand side. The problem with what's happened is our tables come in and it's lying on its side, but you can see that the axis for the table is the same axis for the robot and the same axis for our world. So if we rotate the table, it's very good practice to try and keep the local coordinate system for the object the same as a world coordinate system, or things get a little bit confusing. Okay, so if we go down the tree, we should now find out that we've got the geometry and we've got the table. If we select the table, right click, and you can see we've got two options. We've got edit position, which will physically rotate and move the position of the table. We've also got edit reference frame, so that's the referencing. So if we rotate the table 90 degrees, looks like we're going to have to rotate the reference frame back 90, so it's pointing in the same direction as the robot and the world coordinate system. So click on edit position, and we're going to change in the absolute position, and we're going to rotate in RX and 90. So the table has moved, but you can see the reference frame has also moved, so now it doesn't match the rest. So right click the table in the tree again and select edit reference frame. What you can see, we're still on the modeling tab, that this edit reference frame button is pressed. It's very important that it's a toggle, so when we've finished editing the reference frame, we need to come back here and switch it off. Go to the absolute position of the reference frame. You can see it's been rotated 90. Let's change it back to 0, and it is now pointing in the same direction as the robot and the world. Okay, just zooming up a little bit. What we're going to do is we're going to move the robot to a position on the table that's been defined by a small hole that was modelled in. Firstly, don't forget to select the edit reference frame, so we can select just outside. You can see this little hole here, and we want the center of the robot to be where that hole is. So select the base of the robot. We're in the modeling tab. I'm going to select point to point, so we want to move to that point. And this can be quite frustrating with this software. If you can see when I move, you get in a little square. Depending on if you've got many applications running, you might find that you have to hover over these vertices for some time before that appears. You can see in the top right hand corner it's saying select a point. So hopefully that's okay. There you go, it's jumped and we're in position. Let's just zoom extend so we've got a nice scene. Let's just save our work. So everything's saved. Now what we'd like to do is we're going to bring in a bump tray. It's just another object to just give you a little bit of practice on bringing things into the scene and stuff. So we're in the modeling tab, import, and we're going to go and find our bump tray, open it up, leave it at standard precision, and it will slowly come in. See the bottom right hand corner coming in. Obviously depending on the complexity, and it's how long it will take to import in. So we can see it's here. Let's move it to the side. You can see what's happened again. This tray wants to be on the tabletop. It's coming at 90 degrees out of sync. So with the bump tray selected, go to the tree, right click and edit the position. And again we're going to rotate it to RX 90. But we can see what's happened is our reference frame has now gone out of sync again as expected. So if we right click, edit reference frame, don't forget the toggles come on. Drop this back to 0. And not forget to unselect the reference frame. Okay. So let's change the absolute position of this bump tray to 56 in X, 410 in Y, and 61 in Z. Just going to look at my views. I'll see from the front view. Yeah. It's sticking out a little bit. I'm just going to move it in. Let's see if that looks okay. It's probably a little bit high, but for now it'll do. Go back to the perspective view. Okay. Right, we're nearly there. Save the work again. What we now need to do is our robot hasn't got a gripper. So we need to import the shrunk gripper. So insert, and we've got the grip cam. Open it up, leave it. Now this model has come from the company that we bought the gripper from. But what Chris Staines has done is he's added this sort of fingers, if you can imagine, on the end of them. So you can see it's slowly coming in a more complex model. Okay. Looks like, let's have a look. There you go. Hidden away there. We can see that what's happened here is it's pointing down, our robot is pointing up. So what we'll do is we'll rotate it 180 degrees. Then what will happen is that the reference frame will need rotating back. Then we're going to slowly move it somewhere close to the end of the robot and then attach it. Okay. Things we need to know about grippers and stuff, and there is a very good help in here. So let's go to Stäubli help and do a search for handle maybe controls. Okay, so what we've got here is we're just looking in the PDF that comes with the software. We're quickly looking at a little bit of information on what is a handle and a handler. So the base of a robot is a handle, but more importantly the end of the robot is a handler. A handler can grab a handle, so these are different types of grippers. Some grippers can have multiple handles, so we need to define on the robot the handler, find the handler, and then find the handle of the gripper and attach it. Then we also, on the gripper, we need to define the handler, and this will become the tool center point, so where the gripper will grab things. So it's very important we get the concept of handle and handler. Okay, so all we've got at the moment is an imported 3D object. It doesn't know it's a gripper at the moment, doesn't know anything about handles and handlers. Where if we look at our robot, it's got a base, and it understands the 3D model of the base. Sorry, of the robot. Going back to the gripper, we need to firstly we need to rotate it. So we're going to rotate it 180 degrees this time, so it's pointing upwards. You can see that the coordinate system is pointing in the wrong direction. So get the gripper, right click and edit the reference frame and just bring it back down to 0. So it's pointing in the same direction. Just going to slowly move it somewhere near the end of, sorry, one thing as I keep trying to tell you guys, don't forget to switch off the edit reference frame. Then you can move the object. Just moving it somewhere close. Just to the side a little bit. Okay. Right. So, just going to select the gripper in there, right click and say it's a new tool, not a new part. Parts are things we pick up. So click on there, just reduce the tree, got a new tool, tool 1, the model is there, and we've got the handle and the handler. If we simply selected the gripper and right click and asked it to attach it to the controller, it would probably go to the wrong, well, it will go to the wrong position because we haven't defined the handle and handler yet. So let's get a good view of the base of the gripper, and this can be quite frustrating to do, but I want to get the base of that. Okay, so what we're going to do is going to try and select 3 vertices on here. See if I can rotate it a little bit better. Maybe at the beginning of this curve, the end of that curve, and the beginning of that. By selecting these 3 points, it will get me the centre of that hole. Okay. Select the gripper, it's purple. And we're going to select the handle, and we're going to edit yellow, and we're doing the handle, and we're doing the 3 points. Do it again. So it's gone to 2. Okay. Hopefully after quite a difficult trial and error, if I'm honest, you'll be able to select these. You might have to zoom a little bit closer. You're selecting these vertices here, and what should happen is the handle should jump into position. If you're going in this clockwise motion, that will mean that the handle is pointing in the axis is pointing in the right direction. So let's just maybe go to the front view, zoom right out. Okay. So that looks okay. So if we go to the handler, it's actually not so bad actually, but we are going to put it in the right position, so we need to get a viewpoint. Let's have a look, see if we can get a nice Again, what we're going to do, you can either pick up on this circle here, 3 points, or you can pick on this corner, and this corner. But with the yellow, it can become quite difficult to see where the chamfer has been modelled. So let's see if we can get a better view of it. Sort of there. And so we've got the edit option still selected, and we're just going to get the handler now. So we've got the handler, 3 points. I'm going to try for the outside. There we go. Come on. Eventually, with quite a lot of trial and error, hopefully you've got the handle at the end and in the centre. What you'll find is it's right at the end of the fingertips, if that makes sense. You'd be better just dragging it down halfway height, so that this will be the tool centre point for our robot. Okay, hopefully you're still with us, and the frustration of these handles and handlers hasn't driven you to distraction. Switch off the edit position, zoom at second soul. I'm going to go to the perspective view. Our reference frames are pointing in the same direction, which is great. If you went around the gripper the wrong way, you might have to rotate this through the RX, RY and RZ. You must have them pointing in the same direction. Okay, now what we need to do is send the gripper to the end of the robot. Okay, so with the gripper selected, right click and attach to the controller, which is the TX40 controller and its handler, because you know at the end of there is the handler, and it's jumped to there, attached itself. If it's gone upside down or it's further down, then you've made a mistake with your handle or handler. So save your work, because you've defined your cell. Now what we need to do is give the programming the position of this tool center point. So with the tool selected in the tree, if we right click, we've got device configuration, which we'll be doing later on, edit position and stuff. But if we go further down to the handles and handlers, we have we actually want to go to the handler, right click, and we want to set this point as the tool center point. We also want to the distance from the tool center point to the robot is currently not defined, so we need to right click and copy the tool data. So this will be the distance from the end, the flange, to the handler's position. Okay. Let's get rid of the this window, give us a little bit more space. Go to the data window. Okay. I'm going to go to the controller now, right click and add a new application. We're going to call this robot underscore cell. It will be saving to the place, the subfolders where your Stäubli template DF is. So okay, so we've now got an application starting to build. You'll see it's on all of them. Go back to the data, called robot cell, and we've got a motion descriptor. We've got a default motion descriptor. So how fast, if we ask it to move this fast in the program, it's got a default. If we want to have predefined speeds, we'd have to create some motion descriptors. Okay. What we need to do now is define a tool in here and give it the correct data. Okay, we want to add some new data. What we've got in here is all the different Stäubli types of data. So we've got a motion descriptors, we've got points, J points and joint points, so joint RXs and joint RSs. We're going to be using joint RXs a lot. And we've got the opportunity for strings, digital input, outputs, etc. But what we're going to do, we want to define a tool. We accept that it's going to be called T-tool. So when we call this variable T-tool, it will get the data from here. So now we have this tool. We have the T-tool, and this is the offset, which is the distance from the flange of the robot to the tool center point. Currently set at 0, but we right clicked and copied the data, so now we should be able to go to the very first cell and paste in that distance. Just change the time it takes to open and it's currently set as valve 1. So on the robot, if we open and close valve 1, the gripper will open and close, and it's going to be 0.1 milliseconds, sorry, 0.1 seconds to open and close our gripper. Okay, and save our work, and zoom extents all. Just going to close this, make sure everything's looking okay. Okay, so we can actually see where our work is stored, and now you have your cell, and from now on we're going to carry on adding applications and programming our robot to move. We're going to do some loops, sending signals, input output ports, and things like that. Okay, thank you for listening.